Hello, Chargers. This is Mrs. Boyd.
And this is Charlotte Boyd, yes.
And we're here to teach you today about reflections.
Yes, very much.
All right, so if we want to reflect, there are 3 steps we need to follow. First, create a perpendicular line from each vertex of the figure to the reflection line.
Everyone shall do that.
Okay, so we're going to make this perpendicular line. That means where the line intersects our line of reflection has to be a right angle. So there's one. There's another one from B over here and from C over here as well. All right, we've got 4 corners on our rectangle, and we have 4 perpendicular lines to the reflection line. Now we have to measure that segment. All right, so my line on my computer from A to the vertex line's 4 inches. And then my D is 2 inches. B, and this, again, this is on my computer screen, is 10 inches. And C is 8 inches. So now I'm going to copy that measure to the other side and make a new point. So I want 4 inches is right here, 2 inches is right here, 10 inches way down here, and 8 inches. I'm gonna have to scoot up just a little bit. Eight inches is here. All right, so now that we've got these lines made, I'm going to connect them. So there's 1. And 2. Three. And 4. So we use those points to make a new line or new figure. So mine is not looking super exact, so I'm hopeful that with a ruler on your paper, yours will turn out a little bit better than mine did. So really what this should look like, I mean, it's not awful. It really should be like this. Should be a vertical rectangle, but it's not awful. So that is how we measure these reflections. You're going to need a ruler for this for sure. So be sure you have one handy. Let's label our vertices, A prime, B prime, C prime, and D prime. All right, let's do some more. Oh, for the love of Pete. All right, let's see what we can do here. So we want to reflect. We're going to draw some perpendicular lines here. And then I'm going to measure them. Or actually, I'm just going to kind of play it by ear here. You definitely measure on your own paper. It's really difficult on my screen here. So looks like we're going to connect these 2 points, these 2, and these 2. So that'll be F prime and G prime and E prime. So that's the reflection. Next one, H, I, J, and K. We draw some perpendicular lines. And then we extend those an equal distance on the other side and connect the dots. Oh, that line is so wiggly. So sorry about that. So this is H prime, I prime, J prime, and K prime. All right, one more. This one's a little bit more exciting because we have points on either side of the line of reflection. L is on the left side of the reflection line, and M, N, O, and P are on the other side. So the line of reflection for L will go this way. M, N, O, and P are all going to go that way. So we'll connect all the lines. And we'll have M prime, N prime, L prime, P prime, and O prime. Hooray! So that's pretty much the gist of a reflection without any coordinate grid. Thank goodness it's going to get a whole lot easier once we use a coordinate grid. So if we want to reflect over the x-axis, we're going to take our coordinate points, which are A, B. Let's go ahead and list them in our table of values here. A is -3, 4. B is -3, 1. And C is 0, 1. We're going to take those A and B points and make them A, -B. This will flip our image over the x-axis. So that makes A prime -3, -4. B prime -3, -1. And C prime 0, -1. A stays the exact same the whole time, and B gets the opposite side. Let's plot these new points. So we've got -3, -3, -4 is A prime. B prime is -3, -1. And C prime is 0, -1. Connect our lines here, or connect the dots, I guess. I just found this line tool today, if you couldn't tell, and it's pretty fantastic. So you can tell that we took this original triangle and just took this A point and flipped it down here to the other side of the x-axis. Now, conversely, if we want to flip over the y-axis, we do something a little different. The A, B, and C points are the same. So we start with -3, 4, -3, 1, and 0, 1. I didn't write the points on there, so let me fix that. That's B is -3, 1, and C is 0, 1. So to reflect over the y-axis, we take A and B and do something similar. We have -A, +B. So all of the x values change to a new sign, and the b ones stay the same. So A prime here is going to be +3, +4. B prime, opposite sign for the x value is +3, +1. C prime 0 doesn't have a sign, so it just stays 0. Let's plot our points. So we've got 3, 4 for A prime, 3, 1 for B prime, and 0, 1 for C prime. Put this all together. And we've got a new triangle reflected over, whoopsie, the y-axis. All right. Couple more here. Got to see if I can convince all my shapes to move away. All right, looks like I fixed it. So now we're going to take and reflect over the origin. So let's write our points down again. We've got A is -3, 4. B is 3, -3, 1. C is 0, 1. So we take our points A and B and make them -A, -B. All of the signs flip to the opposite of what they currently are. So A prime will be +3, -4. B prime, +3, -1. C prime, 0 stays, -1. Let's plot our new points. We have 3, -4. C prime 3, -1. Or that's B prime, sorry. And C prime 0, -1. We connect our points together. Oh my gosh. And there we've got a triangle that's been reflected over the origin. Finally, we can reflect over the line y equals x. Just so you remember, that is this line that would go right through here that cuts the origin in half and goes along 1, 1, 2, 2, 3, 3, that kind of a line. So our image is the same. Our points are still -3, 4, -3, 1, and 0, 1. Let me fix this one a little bit. So if we want to move from our regular image and reflect over y equals x, we're going to flip. We're going to flip, oh, God bless me, A and B. So that'll become B and A. So the x and y just trade spots. A prime is going to be 4, -3. B prime is going to be 1, -3. And C prime will be 1, 0. Just A and B flip flop. Let's plot what we've got now. We've got 4, -3 is A prime. 1, -3 is B prime. C prime is 1, 0. And then we connect our dots together. And we've got a triangle that's been reflected over that line. So if we were to use the distance formula, the distance from each of these vertexes would be the same from that y equals x line. This video is not my best. I'm so sorry about that. I hope this is pretty straightforward for you. Just remember the rules here on the back side of the page, and you'll be great. And I hope to see you soon. Bye-bye.